Hello.
Is the microphone working? Hello, okay, good.
All right.
Start off a little bit. It's a real honor to be here in Don's memory. It's true. We did work together. Geez, I started working with Don back 2 jobs before he came to CLTC, and we worked together on projects for EPRI, projects for the CEC, and other organizations. So it's an honor to be here in his name, and thank you all for coming. Another thought or two as we get started, though. I'd like to give you a little bit of background. Many of you in the audience, we know each other, or we certainly know of each other. I've been involved in the work here in Sacramento for almost 30 years now with the California Energy Commission, with the various sub-organizations and committees and everything else we've been through. Certainly been involved with the CLTC since it was still a pipe dream of Michael's when he and Costa were still down at Berkeley. And it's a great program that's evolved out of all this. So we all have an awful lot in common, and I'm also thrilled to be here for that. But I want to introduce something new to us. About 3 years ago almost, I was delivering a lecture in New York City. In a pretty big room full of a lot of people, the governor and the mayor and all that kind of stuff. And this very attractive woman was sitting on my right, and she was doing this program on health and light. Well, the health and light topic has really come alive in the last, well, it's 10 years roughly, since the fundamental science that has given us the basis for what we're going to talk about tonight actually happened. And that was really quite a breakthrough. And Deborah got up and gave the best presentation on the topic, the most concise, well thought out presentation I had heard from anyone in this rapidly evolving field. And I thought, isn't this neat? And so we sat next to each other, and I sort of started elbowing her a little bit and getting to know her a little bit. And I've been very fortunate to build a very strong relationship with her in all ways since then. One of the things, though, that I've known about in my career, and those of you know a little bit about my thing has always been kind of like, how can we do something more responsibly and better? I am the guy who wants to make things work from daylight, from natural sources, use as little energy as possible, have the lightest footprint on the planet as possible. And I started doing that almost 40 years ago. And it was, gee, who was thinking about those things back then? As part of my career, I've also found it interesting to evolve and find the new things. And along comes Deborah with her unbelievable ability to do research and develop ideas about how to address this rapidly evolving topic of health and light. So I'm introducing her to you all as important to me as an important new thing in our rapidly unfolding area we call lighting. And one of the things we're not going to talk about today is going to be LEDs. Well, not much. But we are going to talk about a whole lot else that is affecting the way we need to be looking at lighting as much as anything that has come across in my career. So with that, I would like to introduce to you a perfect circadian day.
Does anybody want to take a guess what's happening there? This little guy, oops, right, let me back it up. This little guy right there is the start of what is going to be a human being. And about 8 to 10 hours later, the result is going to have an immediate and responsive connection to light, environmental light. It's incredible. All throughout the entire developmental process, something is happening, and that something is a connection to the naturally changing cycles of light as well as the ambient temperature. And it changes so that by the time of 28 weeks gestation, the little organism, the little human, is fully developed with a circadian system. In other words, a fully functioning biological clock. But through the birthing process, something unique happens. It goes back to default, to 0. And it takes 4 to 6 months here breathing air and getting the right combination of light and dark and temperature to fully develop once yet again the circadian system. So what Jim and I have done is we've looked at how the human body and brain develop. We've really gone in deep and looked at minute by minute by minute in terms of what happens throughout a 24-hour day inside the body and brain. What happens? And what's happening outside with the natural light and temperature, and what's happening correspondingly to the interior of the body and brain. What's happening? Why is it? I mean, how in the world and why do we constantly want to reach out all the time, reach out for that light? I mean, that's the one thing that we're reaching for, that we're traveling for, that we're moving for. It's always about reaching out to that light. So much so that, I mean, how many times as a little kid have you stood outside, to remember standing outside and just looking up at the stars? I remember the first time I saw the Milky Way, I thought it was somebody cooking something on a barbecue and without smoke. And was like, wow, this is cool. This is the Milky Way? I grew up in Philadelphia, so we didn't have stars, you know. But there was something about the light that always wanted to get your attention, your draw. What is it about that light? You know, so that you notice and you feel differently and you respond differently when the sun changes throughout the day, changing the colors that we're able to perceive. Something happens. Something happens when you look at an ordinary scene, such as this dock off of the beach in upper Lake Michigan. What happens when you see the same setting a few hours later? What's the response that we have? Well, you might say, well, you know, I feel differently, or, ooh, it's a little bit more romantic, or whatever. But there is actually chemicals going on in your body and changing, like dominoes just falling down in response to the light levels as they change over the view of a simple dock. So our program tonight, we're going to give you an idea of what happens here inside this body and brain over a 24-hour period. We're going to set you up. We're going to get you some ideas first because it's a really complex topic. So we want to set you up with some checkpoints that you need to understand. But then when Jim delivers the actual blow by blow, you're going to sit there and be amazed. The first time we did this program was in Madrid a few months ago, and people were like, oh my God, I did not realize the connection. And it's a connection that goes very deep because we respond and need light. We need it for more than just visual acuity. We need it to survive. There you go.
When we talk about light, though, those of us who work in the field of lighting, we've had the pleasure for about 100 and some odd years of being able to throw a switch and have light, and then throw a switch and not. But in fact, in nature's cycles are quite varied. We have the time of year, the time of day, weather, sometimes even other conditions. So we might be enjoying sun rays, we might be enjoying extremely cloudy days in which there's fog or something else, and it seems to change the light character quite a bit. It's also the cycle of the day, what happens at what time during the day. There's a word that is used to describe what light does to the human body. It's a German word called Zeitgeber, which literally means time giver. And so the Zeitgebers themselves, light is not the only Zeitgeber, there's others too, but it is an intrinsic part of what we have to try to understand. For example, understanding that the system works on a sunny day, on a cloudy day. The system works whether it's night or day, but it works in a particular manner relative to those Zeitgebers into the way we're built and the way we're expected to react. Night, as Deborah said just a few minutes ago, is a critical part of this too. And as we'll explain here in a few minutes, the preservation of the night and the preservation of the day are very important parts of us being, I guess you want to say, healthier with respect to the cycles of nature. And then we come along as humans and we invent things. And we invent light, and we invent cities, and we invent intrusions into nature cycles. Sometimes we don't even know how badly we've intruded. But when you talked about seeing the Milky Way, we had a wonderful holiday. Actually, it was a working holiday to put together this program. We went to Door County, Wisconsin, and lying out, looking up at the Milky Way, it was an experience that I'd forgotten how much I missed. And we've come to realize that we have intruded on nature's cycles. It's pretty obvious when you go out and you look at light pollution and you aren't able to enjoy what people have enjoyed centuries prior. But when you start to think this may be affecting our lives and our health, that's pretty serious stuff.
You know, and light pollution is not just from cities. This is light pollution. This is all now being recognized as something else. In some scientific and medical circles, watching television, talking on the telephone, on your computer, your iPad, your iPod, you know, all of that is now being recognized as a Zeitgeber on its own self, in its own right, because this is also driving a response in the body and brain, a measurable response. And that's something that I'm going to touch on to give you an idea of what science and medicine knows, and for whatever reason is not getting out there. So this is what we're doing. We're just sharing information with everyone. And the scientists, they're working very diligently, they're very hard. But for me, I took 16 years of my life and learned something really unique. I learned how to be multilingual. I now speak science, and I speak medicine, and I put it together through design. Because scientists are not talking to the docs, and the docs aren't talking to the scientists, and neither of those two are talking to the designers, and you know that the designers are not sharing the information to the clients, or to the regular person that's on the street, or to the mom and dad whose child's sitting in front of that television. So this is our role. This is the reason why we're doing this. Science is investigating. Oh my gosh, some of the major projects right now are looking at children's health. $100 million NIH grant was issued just to look at the impact of the environment on children's health. And light pollution and the impacts of light on children's health are one of the key topics that are being investigated. Nutritionists. Margaret Aumann is a nutritionist, yes. We're looking at the nutrition values because nutritious cycles, in other words, when we ingest food, this is another Zeitgeber. This is another timekeeper for the body and brain. The time of feeding cycles are key in determining our biological clock and how it responds. You know, someone always seems to ask me, oh my gosh, you know, where is your PhD from? And what's your research project and who's your major funding? Well, I'm a registered interior designer and a licensed general contractor. And I've been doing this work for, like I said, 16 some odd years, 20 years. And it's taken me a number of places. My work has taken me through 7 human autopsies with the Tennessee Medical Examiner's Office, through the ophthalmology suites to where I examine the eyes of individuals from 12 to 90 years of age. And I speak medical and science, and I have been given the talents to make it very, very easily understood by the average person, and this is what I'm going to be doing. I like to say that, you know, Jim and I are reporters. We're investigative reporters, delving in and making sense of all of this stuff that the scientists and the medical professional are talking about, and they're not bringing it from bench to bedside or from knowledge to practice fast enough. And lighting is taking off like a bolt of light. You know, I don't want to be a pun here, but it's taking off so quickly. We need to be able to understand it. before we get too far and we can't rein it in. So our focus of our work is through circadian involvement and understanding the circadian system. This is some of the information that you guys are going to have to start understanding, because the wave of the future is about understanding how light and feeding times and temperature directly impact our body and brain, with chemical reactions, with physiological, behavioral, and emotional reactions and response. So we go in and understand and do the investigative and theoretical and exploratory research in circadian system, circadian rhythm, and sleep-wake cycle. And your first bit of information that I want you to keep under your hat and really understand is all three of those are different. So when someone's saying, oh yeah, my circadian rhythm's off, that's totally different than the circadian system or the sleep-wake cycle. It's three totally different, but yet totally interconnected bits of information. Circa meaning approximately, diem, day, circadian. And for me, it's simple. So when folks ask me, well, what do I do? Well, I make it simple. I do this. I connect dots. I'm the world's best dot connector. That's what I do. That's my role. I connect the dots. And as such, I have to ask the tough questions. And for me, I'm a visual learner. So having a television background, and for years I did television, live television. So, as a producer once told me many, many years ago, he said, Deborah, if you're on camera and your mouth is moving and your hands aren't doing something, it's called radio. So when I am trying to my audiences explain something as complex as an epigenetic marker, I remember my television days. Because to understand circadian system, circadian rhythm, and sleep-wake cycle, you have to understand epigenetics. So here's my easy-to-understand version of how genetics work. My arm, my bare arm, is a chromatin of DNA. DNA, of course, is hereditary material, and it has a sequence of nucleotides that are arranged that do not change throughout our lifetime. This is what represents on my arm, and I'm wearing the bracelets. I started this about 10 years ago, and now apparently I have a trend going, because everywhere I go I see women with lots of bracelets. But I use them to teach genetics. So here we have the A, T, C's, and G's. And so the A, T, C's, and G's are the nucleotides of DNA. The job of these A, T, C's, and G's are to turn on, express, to stay the same, or to go to sleep, just to remain silent. And each one of those three actions is going to be precipitating of a downstream response. It's just like dominoes. You know when you line the dominoes up and you click or flick the first one and everything starts cascading down? Well, that's what happens when these genes turn on or off in a set pattern. It's called a neurohormonal chemical response. So you have the chromatin and you have these A, T, C's, and G's. Over top is a protein sleeve. And on top of this sleeve sits a little marker, the epigenetic marker. We have 35,000 plus genes that we know of right now. 51% are what are termed regulatory genes. And what they do is they read the environment until they get the right signal. They read this environment and they read this environment. And when they get the right signal, they pull the sleeve up and the gene sequence turns on or off. Problem comes, sleeves down, and the epi marker's not getting the right sequence of signals. It's not getting the right signals at the right time of day when it's programmed to do so. So consequently, the sleeve stays down, and what happens to the genes? Yeah, nothing. They're getting the wrong signal at the wrong time of day. And we now know a number of genes. We have them named. We can identify them. And a good portion of those genes are involved in circadian system, circadian rhythm, and sleep-wake cycle. And that's the reason why I'm a member of the American Academy of Sleep Medicine, because I know the research is involved in sleep. And it's through sleep that we have the hard economic facts, and we have the data to show how and why environmental light and temperature really impact the human animal, and it has an economic consequence. So I like to also say that The one thing you have to keep in mind for understanding sleep, it's like we're a goldfish in a bowl. You know, anybody here ever have goldfish? Your kid bring home goldfish? Okay, what happens when you don't change the water? You know, or if like the dog decides to lap it up, or your small child throws a candy in the water. Well, this goldfish is going to go belly up pretty quick, because anything that happens in the goldfish's environment, he's going to notice it immediately. And that's what happens to us. It's our environment. And sleep is predicated on our environmental diet of light. Because in order to get what's called an efficacious sleep, which is circadian system, rhythm, and sleep-wake cycle, we have to understand that the process of sleep starts during the day. The amount, the quantity, the percentage, the timing, and the duration of the light we receive during the day determines, very simply, how much sleep we get at night and how efficacious or how efficient we are at getting the right sleep. So if we're not getting the right amount of light during the day, and very few of us these days that are working outdoors, we're working inside, well, guess what? We may not be fully awake even at 12 o'clock in the afternoon. So consequently, we're not going to be able to get to sleep at night. And science is backing us up on this. They're leading the way. You know, we know throughout our lifespan we have different requirements. Small children, up until the age of 6 months, require anywhere from 18 to 22 hours of sleep. Nursing mothers, anywhere from 9 to 10 hours. And adults, we need 7 to 8 hours. Teenagers, by the way, need more. They have a different brain physiology. When I go into the autopsy suite and look at the teenage brain as compared to a fully emerging, adult male, there's a difference. And they have a sleep requirement. 19 counties here in the United States have recognized that and have started delaying the start of school until 9 o'clock. And they are doing it because of the circadian need of the teenage brain. And the downshoot, or the impact of that, is that crash rates and accident rates are dropping dramatically because the teenagers driving to school are not sleep deprived and they are fully awake, simply by delaying the start of school by 1 hour. And it's all based on the scientific evidence that Jim and I understand and that we're sharing with you. And all of the design and architectural community can understand and prosper from knowing how sleep plays an important role. Because every one of these segments of the architectural and design and engineering communities can fully involve themselves in understanding how sleep and circadian systems work. And if they do, they are not only providing a benefit for their client, but they're taking another step forward to helping mankind in general. And this is the reason why we do what we do in connecting dots. Sleep connection. You know, so many things are connected with sleep. Wound healing, learning, memory, disease, and metabolism. And I'll be sharing just a recent discovery that just happened a few months ago that will knock your socks off. It's incredible. Hospitals right now, the number one reason that hospitals are scurrying in terms of trying to make a profit is because their profitability is getting cut because their patients are returning to the hospital. Major bit of legislation that was passed in October just this past year. So their Medicaid reimbursements are being impacted by the number of people that are returning to the hospital after an illness. And one of the reasons that they're returning is because they're not getting the right amount of sleep, which is causing an aggravated health condition. So sleep is even playing to that bottom line as well. Doctors and medical professionals, their error rates, dramatic increase simply by changing light levels and understanding how the circadian system works. You know, we think of sleep as something that we just do in our beds at night, and it's not. It's a metabolic process that happens 24 hours a day, every single day, and it's extremely important. This is a piece of research that came out of the University of Oregon just a few weeks ago, And this is a fly brain. And you're going, oh, okay, what's the deal about the fly brain? Well, this is the first step in understanding what happens physiologically when the fly is not getting the right signals to keep his or her biological clock in function. These little things right here, these are called vacuoles. In other words, they're holes. They're holes. And in the scientific laboratories, it takes, in some cases, 2 milliseconds of the wrong type of light at the wrong type of day to stop production of a very key hormone. In other words, 2 milliseconds exposure, epi gets the wrong signal, sleeve comes up, and the wrong gene is expressed or it's not expressed in laboratory conditions. And we're now starting to understand the ramifications because just last year, science and medicine are starting to join forces and bringing it to real-world research trials. We're getting much quicker, getting the information from bench to bedside. And you know, we have a dollar figure assigned to it. Harvard came out with this study showing that newly diagnosed cancers have an extremely high economic burden, $300 billion every year. And you know, the researchers in circadian system and photobiology and circadian physiology are paying attention. They're paying attention dramatically. Does anybody want to take a guess what this is? It's a breast cancer cell. Research is done by 2 wonderful guys, Dave Blask and Steve Hill, and they were doing some work, and I heard about them, so I thought, oh my gosh. So I told Jim, I got a plane ticket and went on down there. And I got firsthand information as to how and why light has a huge role in whether this guy spreads or it even starts in the first place. And just look at these numbers, 1.5 million new cases every year. Just here in the United States alone, 13,000 pediatric cases, and that's not including the men who develop breast cancer. 1 in 8 women worldwide, CDC research. This is a problem. A number of reports are showing that there seems to be a relationship between light and breast cancer. So Steve and Dave, they decided to explore it further. And what they found was this. And this is the type of information that I had to wade all those years through. You should have seen my assistant and I trying to have medical dictionaries over here and scientific, textbooks over here and trying to figure out all the languaging and figuring out how and what this means. But without going into detail, basically what it means, this is showing the progression and metastasize of cancer. And this right here is the primary circadian gene. In other words, this little sleeve that goes up and down. And they're showing that light at night is a major circadian disruption so that it will impact melatonin through a gene called MT1. And it is now the only thing in their research, and a number of worldwide researchers are supporting it, that's stopping cancer to grow. Here's the medical slide. In the future, lighting designers, architects and designers are going to need to know this information because the spaces we design, the lighting we provide is doing a lot more than just having you get from point A to point B without tripping. It's very, very important. And this was a major piece that just came out recently. It's another gene by the name of KLF14. And this is involved in metabolic processing. In other words, how fat gets from one point to another point in your body. And it's the master metabolic gene. And the interesting thing about this gene, it encodes melatonin and MT2. So in other words, this gene right here is not going to do what it does unless it gets the signal from melatonin. And melatonin is one of the hormones that is critically involved in the circadian system, the circadian rhythm, and the sleep-wake cycle. Key bits of information. And you know, when you stop and look at it, bottom line is that light is nothing more than a switch. It turns on everything. Everything that we know, that we call human, is turned on by light.
And to, don't use the laser anymore. This thing's going to die.
Oh no.
Yeah.
We're going to have to give you our sung and danced then without slides.
One of the things that I'm okay. One of the things that concerned me a little bit as I started following all of this was there's a real chance and a real risk of misinformation. To read certain newspaper reports or certain things you can find on the internet today, there are some people who are already jumping to the conclusion that there are certain direct correlations between turning on a light and cancer. Well, it's not that simple. I hope Deborah's made that point. It's not that simple. It's not a simple cause and effect. If you do this, then that. It's far more complicated than that. So we have to do more research. One of the key phrases that those of us looking at this like to use or like to talk about is dose. When we talk about anything that we treat ourselves with in terms of medicines, it's a dose. A certain amount will have a certain impact on your body. In the case of light, there's 4 things that so far have been identified as being critical to this process. Number 1 is going to be the intensity. How much light? One of the things we know is that so far the indication is that you don't have too many effects during the daytime cycle if the light levels aren't at least about 1,000 lux. So you need a certain amount of light at day, you need a certain amount of dark at night. Second thing is duration. How long does it last? Early research in people dealing with sleep disorders and especially a seasonal affective disorder suggested that you had to have at least 3,000 lux of light for at least 45 minutes. And when the timing during your cycle had to be when you got up. To this day, that stands as one of the more recommended treatments for seasonal affective disorder. But there's also this thing called spectrum. We talk about light pretty generally. We talk in terms of white light, and as we all know, there's lots of different types of white light. What the spectrum will need to be is going to be one of the big challenges. When we looked at, now I'm going to put on my International Dark Sky Association hat for a moment. I've been serving on the board and the technical committee of IDA for about 10 years. And one of the things that happened about 3 years ago is we saw the correlation between the human circadian response curve, there it is right there. The human system responds to light affected by that particular spectrum. And we saw the direct correlation between that and this extreme blue peak of LED lighting, particularly LED lighting generated by a blue LED and then a white phosphor. And we said, that's not a great idea. That couldn't be a great idea because we look at high pressure sodium lighting, with we already create a lot of light pollution, and we said, this isn't so hot, but most of the radiation is at wavelengths longer than 550 nanometers, and the human circadian response curve is way over here at somewhere between 460 and 480, so this isn't too bad. If we go to metal halide lighting, particularly ceramic metal halide, well, there's an increased amount of radiation in the area of concern, but still most of the energy is down here. When we started looking at these high color temperature LEDs, we saw up to 40% of the radiant energy of these new light sources directly overlaying the human circadian response curve. We said, this is not a good idea because the human circadian response curve is probably very close to, generally speaking, mammalian. But it also has impacts upon insects and all other forms of life. So we start going, this is beginning to sound like, improving the world by adding more pollution. And we stood up against the onslaught of the push to put LEDs in everywhere. And we've made a lot of progress in getting people to slow down and look at the spectral impacts on the environment. Most recently, we've done some testing, working with people on the Big Island of Hawaii to replace high-pressure sodium lighting with filtered LED that has very little radiation and wavelengths shorter than 500 nanometers with a lot of success. So it's all of the things that we may have learned about light and lighting need to be re-examined. Some of our objectives then, as we proceed forward, is first of all, to understand not only the human, but indeed the circadian cycles and circadian systems of all living beings that we might affect them. It would be crazy for us to introduce lighting systems that made things worse. We need to really be aware of the chronobiology of light and the human function. There is pressure right now for legislation in Germany to require daylight emulating lighting systems inside in schools. I don't know how quickly it will move. I don't know if it will even be successful. But it shows how much interest there is in this. And part of the reason is because it is very exciting and it's stuff we might be able to do better. But the other reason is because people are seeing this as a way of introducing products very quickly, and we need to be careful not to rush them into the marketplace. And Deborah and I spent a lot of time talking about philosophy, about how we share this with the community. When developing protocols, the American Institute of Architects gets together experts who have been doing projects leading into new fields of how you apply light. And they develop protocols for how you design this type of room or that type of room. We see this as an opportunity. In fact, some things we're going to show you in a few minutes we've actually shared with the IES already, and they're looking at this as a way of addressing space design and space design protocols so that we can all do a better job. Now, I'd like to start off, though, with the best part, I think, of this program in terms of giving you a lot of information real fast. We're going to get into our dashboard. But I want to start off telling you a little bit about where we go from here. Well, I'm going to start off with the assumption that we're going to be at the autumnal equinox, sunrise at, and we even picked Chicago, 41 degrees north latitude, about almost on latitude with Sacramento. The astronomical twilight, it starts at 5:05 a.m. and ends at 20:20 p.m. The autumnal equinox, the sunrise, sunset, solar noon, there's nautical twilight and civil twilight. And to understand these, you might want to do a little research, but astronomical twilight is when there's just, you're on the transition between the sky being dark and the sky starting to become light. Nautical twilight is where you can literally distinguish between the water and the ocean when you're out on the ocean. And finally, civil twilight is where there's a distinct enough difference that you recognize it on land. All of these are important in the cycle. Is this me still?
Nope, I can take it. We work very well together. The things that you're going to need to know, in addition to what Jim just explained about how we set up the dashboard, you have to have a little bit of background information, and you have to have the right tools. I mean, how can you get a job done, without the right tools and without knowing how to use these tools? So we're going to be taking a small course in circadian system, the pathways, the dynamics, the how and why the system works, the chemicals involved, and the terminology. So there's going to be a few words that you guys better pay attention to because you're going to be hearing it. Because the big thing in lighting right now, and it's going to continue for the next probably 20 to 25 years, is light and light and health. LEDs and light and health. And these words that I'm going to be, giving you, this information, this is going to be the top of everyone's hit list for years to come. The circadian system, you have to understand it, is a system very similar. And in most cases, well, I say most cases, in most scientific and medical circles, it is the preeminent, it is the dominant system over the skeletal system, over the endocrine system, over the blood venous system, over all of the systems, because the circadian system keeps the organism running. Without a circadian system, it just doesn't work. Circadian system is comprised of the circadian rhythm, which is one of many rhythms. Circadian rhythm is something that occurs every 24 hours, and every organ in the body has a clock in it. The heart has a clock, the liver has a clock, and they all work on different time schedules. But the circadian rhythm keeps charge of the 8-hour liver clock, the clock that's in the heart, the clock that is in each and every one of our blood cells. Even the red blood cells have their own, each individual biological clock. Incredible. And they all are subservient to the circadian rhythm. The sleep-wake cycle is different. Yes, it pays attention to the circadian rhythm, but it's a process. It's a restorative process. It's catabolic and anabolic at the same time. In other words, it makes energy and it uses energy. And it's the only process that we have that's under the direction of both a ingrained circadian system impact and willful behavior. We can will ourselves to finish that last bit of a project and stay up and pull an all-nighter. We can will ourselves to do that. Unlike any other mammal. When was the last time you saw the bear saying, well, I got to go hunt up a few more berries? You know, instead of taking sleep, that bear's going to get the sleep it needs. Now, what we now know since 2002 is a major discovery. And this discovery has to do with the way that we get the information into the circadian system. And basically, we're talking about an area right here on the lower portion, the inferior portion of the eyeball. This is where, you know, your lens. Oh, I won't use a laser, otherwise we'll be out of a pointer here. But right down there at the bottom, this is where a new set of cells have been located, intrinsic photosensitive retinal ganglial cells, IPRGCs. Now, we have several million of them, and they're all within the ocular structure. But only 1% to 3% of these cells are involved in getting the light that we need to entrain or to impact the circadian system. They reside on that lower portion. I'm also going to be talking about an SCN, or suprachiasmatic nuclei. That's the scientific and medical name for the biological clock. And it's a tiny little structure. I mean, the first time I saw it, no bigger than my little fingernail. And it's comprised of about 20,000 cells. And keeping the suprachiasmatic nuclei happy is one reason why we have jet lag and several other problems. Because the top portion's not talking to the bottom portion of the suprachiasmatic nuclei. And we get it to talk to each other simply by getting the right amount of light and the right percentage and the right intensity, in other words, a dose of light, and then we get them coordinated back again. And right down here where you can't really see it is a word called the hypothalamus, and this is a structure within the brain. So the way the light comes in, basically what happens, light comes in and it will be knocked down to the bottom. Okay. He's going to change my batteries for a minute. So basically, the light is going to come down from the bottom where you see the tail end of the blue, and it's going to progress throughout the area of the brain that is not a part of the optic nerve. So our visual system goes one way, and the light that is determined, that is deemed, that is harvested for circadian entrainment goes a totally different way. And this is the part, thank you, that is so important, because as the light comes in, the light coming into the biological clock is going right here. It's going right dead center, right here, back about that far. And it's going to hit those cells that are the same size as my little fingernail. And those cells are the SCN. The other light that we receive to get from point A to point B, in other words, our visual acuity light, it travels 7 steps from here, jumps 7 different areas, 7 synaptic steps, to right back here on the brain, and then it comes 3 steps further, and then we go, oh, he's got a pink shirt on, or she has an orange sweater. So it goes through several different processing areas before we recognize that's a color. The type of light that we're talking about, the type of brain portion, the area of the brain portion that we're speaking when we talk about circadian system is involved right here. So, the light comes in, you have to figure out what's happening here. Light's coming in, and as light comes in, we know that light, electric light and natural light, is going to be, according to the body, the way the body receives the light information, it's going to be broken up into different colorations or spectral arrays of light itself. What the body is looking for and what the brain is using to set its clock is a dosing protocol of timing, intensity, duration, the wavelength, the spectral characterization of the light itself. In other words, a 630 nanometer wavelength of red versus a 459 or 479 of blue. The body and brain are reading and searching for that information. And what the process that they're looking for is an equal balance, a bistability. The right amount of blue, the right amount of red, and this is what you have. This is, in the body's language, it's called homeostasis. And if we're getting the wrong amount of blue and the wrong amount of red at the wrong time, this is what we get. Nothing. We stop, or we get this, and we're stuck. The optimal environment is this in the body and brain. Equal balance of both red wavelength and blue wavelength in the correct dosing schedule and protocol. So here's my old television director in my ear saying, okay, you got to show them something. All right, well, here's how it works. This is really simple. So as the Earth is rotating, it's getting different light levels from the sun, different dynamic light conditions, going from predominantly blue-rich in the morning to red-rich in the later afternoon and throughout the evening. So as it's changing, something in the body is paying attention. And that body is 51% of our genes, the epi marker, and the sleeve, the little guy on top of the sleeve, is pulling up the sleeve over top of two very important genes, BMAL1 and clock. When these guys, they pay attention. That's my Philadelphia accent coming out, by the way. So when BMAL1 and clock get the signal, they then send a signal to the circadian system. The circadian system is overcharged. It's master of the heart, the liver, the biological function. How many times you get up in the middle of the night to pee is determined by the circadian system. Incredible amount of detail is under the domain of the circadian system. Circadian system is then regulating the circadian rhythm, everything that happens on a regular basis over 24 hours. That, in turn, is impacting how the hormones, the larger molecules in our body and brain that will set about mostly behavioral impacts. You know, how great we feel in the morning, how frisky we are to our loved ones. You know, how our recognition and our cognition levels function. Primarily at night is when the hormones are released. During the daytime, it's neurotransmitters. And both the hormones and the neurotransmitters pay attention to the light levels. When they pay attention, different genes, sleep genes, are released, as well as other genes within the body. That then sets up a different system, the sleep-wake system. Sleep, in other words, we get the impact to sleep where growth and reproduction and development happen at night when we truly are involved in the sleep process. And sleep is also a daytime process where we are using up, we're catabolizing a lot of the things that we have grown and developed in the evening hours. It's this. It's a yin and a yang. It's an up and down. And when that happens, circadian system is also feeding the sleep-wake cycle a group of other signals, and the Earth itself, by its changing dynamic light conditions, is supporting the sleep-wake cycle. All of this is interrelated. And since 2002, we're finding out that right here, the color of electric light is doing the same job. Who knew? So what we have, our evolutionary designed system that is designed to pay attention to the changing temperature and light cycles. The electric light that we provide in our built spaces are doing the exact same thing. So we had better pay attention to what's happening because the body's paying attention, the hormones. Melatonin, cortisol, and ghrelin are three key hormones that are really paying attention. Melatonin is not just a hormone that keeps you to sleep. It's the major DNA protectorant that keeps these ATCs and Gs viable so that they don't, default, so they don't stop working. And it's the major tumor suppressant in the body. And it works like this with the immune system. And melatonin is a darkness derived. If it gets light, melatonin doesn't come out to work. If it gets light at the wrong time in the 24-hour cycle, it's not going to do its job. Several key pieces of research have come out recently that have shown that ordinary residential bedroom lighting, if it's the wrong type of light up to 3 hours prior to melatonin's optimal time of expression, is enough to impact up to 99% of the melatonin that is produced every 24 hours. So light matters. Cortisol. This is a hormone that is derived from the kidneys. It's a major stressor. It is also tied to the light levels on the bottom of the eye through norepinephrine and other stress chemicals. So he's telling me my time cues. I'm so sorry. He does that from time to time. So I will hurry this up. But it is the major reason why we have some very interesting facts for how and why we need to keep cortisol happy. And ghrelin, a major hormone that stimulates our appetite, and it controls so much more that we are just now finding out. We have neurotransmitters such as serotonin responsible for our mood, our pain and motion control, as well as how well we move our bowels every morning. It's all dependent upon serotonin and the peristaltic action. And guess what? Serotonin pays attention to the light itself as well. Either from here or outside, serotonin is paying attention. And we have naturally critical times. From 1900 to 2100 is the most unstable for blood pressure. 2300 is the time that we have most of the hospital errors occurring. We have a highest rate for kids' accidents at 1600, 4 o'clock in the afternoon. Most likely for allergic attacks at 2300. It all is because of the fact that the body is not getting the right signals at the right time of day. The sleeve is not going up and down as planned. And this is the way the body is responding. Now, the dashboard that Jim's spoken about, this is key. And so pay attention to the changing levels that you'll see across the bottom of the screen and the top, because this is your body exposed to light.
Now we got a little bit of a problem down here. These, I'm going to have to tell you what's going on because this image is a little bit bigger than the screen. So there's no way to fix this, right? Okay, so I'll just have to tell you what's going on. What we did, we literally spent several days doing this, is put together this dashboard, and it's sort of a clock about what's going on. And to go through it very quickly, the dashboard, first of all, we want to talk about the vital signs. What happens to the core body temperature, heart rate, blood pressure, and respiration at every time of the day, and how it's related to your metabolism, how that's related to these neurochemicals of melatonin, cortisol, serotonin, and ghrelin, how that is related to natural light, the solar time, the light level, the color, and the dominant wavelengths, and how that, of course, is related to a clock, which we can't quite see down here. So I'm going to have to tell you what time this is, more or less. We're going to start out at midnight. You've been in bed, you're sound asleep, and what's happening to you? Well, the first thing we know is that your core body temperature is falling. We're starting at 00, midnight. That's the time of the highest cell regeneration, highest level of overall metabolism, and at 1 o'clock, things start to change. Your heart rate is steady, your core body temperature has been falling, your blood pressure is remaining steady, your respiration is steady, but your metabolism is at a peak. This one really surprised me, but in fact, there's something about 1 o'clock in the morning, 2 o'clock in the morning causes your metabolism to reach a peak. Your melatonin level, of course, is high. Melatonin has been called the vampire enzyme because it only comes out at night. Cortisol is low, serotonin is low, and what's ghrelin at this point?
Ghrelin is also making a movement. Ghrelin is moving dramatically. So this is one of the key reasons
But
why
moving where?
It's moving, it's actually rising. And you're thinking, why is ghrelin rising at 2 o'clock in the morning? Well, this is actually a survival mechanism, but the interesting thing is that when you get up at 2 o'clock in the morning and you're going, oh, well, I can't get back to sleep, so I might as well have a snack, it's the wrong time of day to feed ghrelin because it's going to end up right here.
Not in there, on there.
On there, yes, on there, literally on there.
Now, one of the other things that's going on with light is at this point it's dark. And one of the discussions we focus on a lot is what is the dominant wavelength at any given time, because that is a Zeitgeber. But with the light levels so low, as they should be at least at this point, there's not much in saying much about that because the light levels are down in the neighborhood of 0.01 lux. We're not talking about any light to which you would ordinarily be exposed. Between 1 and 2, it's the highest daily level of ghrelin. There's the answer. And at 2 o'clock in the morning, growth hormones are at the peak of their secretion. So this may be a little bit of a clue as to what's going on, particularly if you're children or even young adults. But you have your deepest sleep begins around here about 2 o'clock too. And it's the peak level of melatonin. So melatonin, as Deborah's pointed out, is key to the process, and we can see that it's peaking right in here when you would expect it to occur. The next phase we're going to look at begins to be about 2 in the morning and moving on. The other thing about 2 o'clock in the morning, which you probably feel, it's the lowest level of stress hormones. Your core body temperature continues to fall, your heart rate is steady, your blood pressure begins to fall, respiration is steady, your metabolism now starts to fall back down again, melatonin is still at its peak, cortisol is still at its lowest, serotonin is very low, and ghrelin is starting to fall?
Steady.
Steady.
It's starting to
So it's
just level out.
steady. Again, there's not much light. We're not paying much attention to light here. We're expecting it to be dark. Falling blood pressure, falling core body temperature continues. 3 o'clock, melatonin starts to drop significantly. So we're starting to lose our melatonin peak. 4 o'clock in the morning is your lowest blood pressure, your lowest respiration, and your lowest breathing. So 4 o'clock is the deadest dead sleep in many ways as your body might be seen from outside. Your melatonin, again, goes lowest level, but cortisol begins to rise at about 4:30. And your lowest core body temperature occurs just before dawn. I don't know about you, that's when I seem to get the coldest. They say you get the coldest just before dawn. There's a reason. And it's not just the fact that it's cold outside.
The main reason is that this is your body's cue to begin waking you up. The body is paying attention through melatonin receptors in the skin and through the eyes, whether they're closed or not, to the light levels to be able to give you that signal to send cortisol so that you have the energy or the desire to go, okay, I'm starting to pay attention.
Now we come along about 5 o'clock in the morning. Your cortisol rises steadily and melatonin really starts to drop. So we see your core body temperature now starts to rise, heart rate remains steady, blood pressure steady, respiration steady. Your metabolism is at a peak. So it's been kind of high all night, but it's really hitting a peak about 5 a.m. Melatonin falling now, it's getting ready for the day. Cortisol is rising to meet the day, serotonin is low, and ghrelin is, what's it doing?
It's actually having a second peak. It's moving again. Ghrelin is one of those hormones that really does not work on a true 24-hour cycle. It rises and falls significantly, and that's the reason why feeding times is a key factor playing in almost as importantly as temperature and light for regulating the biological clock. So you want to eat at certain times, and the worst thing you can do for your body and brain is to feed the hunger that ghrelin is naturally producing.
Somewhere around here, the body temperature starts to steadily rise. We have nautical sunrise about this point. So this is a point where you could barely distinguish, but be able to distinguish between water and sky. Civil sunrise occurs somewhere in the neighborhood of about within an hour. So somewhere around about 6 o'clock in Chicago on the autumnal equinox, you're going to have civil sunrise, and you're actually going to really know the difference. You know that the sun is on its way up. Your blood pressure rises sharply. You have the lowest insulin blood density levels, pulse rate and oxygen saturation increases, circulating sleep hormones and melatonin bottom out, so your body's saying, time to wake up. Adenosine increases to promote waking, the blood density decreases overall, and suddenly you hit sunrise. So in other words, the waking begins before sunrise, but it all leads up to sunrise.
And one thing that I'd like to interject here is that the majority of heart attacks occur during a very key critical time between 6 o'clock and 8:30 in the morning because of everything that Jim has just highlighted with you about the blood density levels, the cortisol rising, and the bottoming out of the melatonin, and the switch to the cortisol levels and Gerolin's impact on that as well.
No,
so this is very key and critical information that we as lighting designers, AE and ID professionals need to understand, because we have to design to protect and support that body and brain.
In nature's time frame, the light intensity now is going to change very quickly. A lot of people want to say, well, what color temperature is the light? Walk around with a color temperature meter, and it depends upon where you point it. If you point it right at the rising sun, you're going to get 2,500, 2,600 Kelvin. Point it at the blue sky behind you, you're going to get 10,000 Kelvin. So what color temperature is it? It really depends upon which direction you're looking. But the dominant wavelengths that are going to be in your field of view are going to be low color temperature, but only briefly. It rises very quickly. It rises faster than it falls, in other words, and the blues begin to enter back into the spectrum, and you see the color temperature of the light raise very rapidly, as does the intensity. Around 6:45, you get the sharpest spike in blood pressure. At 7:30, the melatonin production stops completely. At 8 o'clock, you have the highest risk for heart attack and stroke. As Deborah pointed out, this is where this is all led up to, your greatest period of risk. The morning peak Gerolin levels begin to drop. You have the highest pain sensitivity for arthritis at this point in time. T-cell lymphocytes are at their lowest circulating level, and around 8:30, you're most likely to have a bowel movement if you're on the normal circadian cycle. At 9 o'clock, the highest testosterone secretion occurs. At 9:30, you begin the highest levels of circulating serotonin. And of course, the daylight is now increased so that on a cloudy day, you may only have 10,000 lux, but on a sunny day, you'll have 100,000 lux, and the color temperature will be hot. The presence of those short wavelengths trigger the systems. The Zeitgebers are really out in force. About 10 o'clock, we have minimum Gerolin levels as that drops. We have the highest alertness and attention, though. So this is a really good time, 10 o'clock in the morning, to do something really important. You're your sharpest then, or at least one of your sharpest. Highest memory and concentration. You make your best decisions in problem solving. And if you haven't noticed this about yourself, think about it tomorrow at 10 o'clock. Gerolin is rising to a peak, and now we're starting to come into noon to 2 o'clock.
And then if I can just interject the fact that at 10 o'clock, most of us will have a 10 o'clock water cooler experience, or, oh, I got to have something sweet or some kind of a crunchy. And that's because Gerolin is taking a very dramatic shift. It's at its minimum, lowest level, and then very quickly it rises again. So as it goes through a very, very strong dip and rise, we are going to respond behaviorally by going, oh, now's the perfect time for a cup of coffee, and I'll just take one of those scones or danishes as well. So
yeah,
it's the
they
body.
are good, aren't they?
It's the body's response. And it's saying, I need a little bit of sugar. I need a little bit of something at this time.
Notice that this is the prime time for photomelanoma
metabolism.
Yeah.
And basically, this is just vitamin D synthesization. And this occurs between 11:30 and 3 o'clock. This is the prime opportunity to get your 20-minute dose of vitamin D. And vitamin D is something that happens in the skin, but it is the availability of the UVB wavelengths actually connecting with the fat or with cholesterol that's found in the skin. And then that starts the conversion process to vitamin D2, to D3, that involves all of the circadian system hormones as well.
And at this latitude, we're actually at a point where during the winter, we don't get enough UVB. We don't expose our skin enough, and there's not enough present, really, to give us this dose.
Anything above 34 degrees latitude, and we are deficient in the amount and the quality and the dose of light in order to naturally start the vitamin D or the photomelanoma metabolism process.
So in other words,
you
need supplements.
Yes.
You need supplements. In this latitude, and of course further north, the more you need the supplements. Coming back to one of the other things that's happened, your metabolism is actually falling at this point. And a number of other things, you study basically behavior of your core body functions, but you can see how the serotonin is maintaining steady, our ghrelin is rising again. Ghrelin's rising again, melatonin of course is low, and cortisol is now beginning to fall. As we move into the afternoon, the lowest daytime performance level is right at noon. It's a good time for lunch because you're not going to perform as well as you were just 2 hours prior. Serotonin levels begin to decrease, highest blood density level, onset of sharp decrease in ghrelin. And from 1 o'clock to about 2 o'clock, your energy levels and vitality are at your daily low. Have you ever noticed that right after lunch? You just, well, there's a reason. And the reason is this entire structure, how your body is behaving. Cortisol is falling, melatonin is low, serotonin is falling, and ghrelin is where at this point?
Remember, you have to have this. Ghrelin is falling. Ghrelin is one of those hormones that constantly goes up and down and up and down. And we have to figure out how to utilize ghrelin naturally. And ghrelin is another one of those hormones that seems, at this point, the research is showing that there may be, and I'm using these setup words because the research is not definitive, but there seems to be a connection between light and temperature as well as the ghrelin itself. And you'll see a little bit later on.
Well, 2 o'clock, you're hitting your second lowest ghrelin levels of the day. Oddly enough, though, about 2:30, you have your best hand-eye and muscle coordination. So this would be a good time to, I don't know, whatever you might do, we took advantage of that. As we get later in the afternoon, first of all, one of the things that's happened is the light levels are now going to start to fall. A slow diminishing of color temperature is going to occur, so the light starts to warm up. And at about 3 o'clock, the greatest grip strength and muscle tone is the way you're going to feel. You can see rising blood pressure, peak respiration, peak metabolism. We went from low to peak in about 3 hours. This is one of the reasons why you have this. So the highest breathing and respiration rate, reflexes are at their greatest sensitivities. Afternoon productivity begins to increase. So starting about 3 o'clock, you should be really great. You should be feeling pretty fantastic. By 3:30, you have your fastest reaction time. Boy, if you were going to play sports, this is the time to do it. 4:30, the blood pressure is the highest. Again, at 5:30, you have the peak serotonin surge now as the body starts to start the end of the day getting ready for the night. And your peak afternoon productivity occurs right just about the time you're driving home from work. And then we have sunset. Sunset's an interesting process because of atmospheric conditions and everything else. The longer wavelengths prevail for a longer period than they do in the morning. So you have a diminishing light level, but you also have a changing color temperature of the light. These are important zeitgebers. As we go into the early evening, we start to see some of the things that happen. You have your peak core body temperature right around 7 o'clock. Steady heart rate, steady respiration and blood pressure. Your metabolism is peaking again. Your melatonin levels are low, but cortisol is falling, serotonin is falling, ghrelin is doing what?
Rising.
Changing again. But the light levels are very low now. Now we're into night. This is the period where I think we're going to find in research in the next couple of years that there's some critical things we do right and some critical things we do wrong. When somebody asks me, what should I be doing at 7 o'clock in the evening relative to light? I say, well, no one knows for sure. But one of the clues we have is that nature makes it dark outside. We might want to start thinking about what light sources we use and what we do with them. As Deborah showed you a photograph earlier of someone watching TV, keep in mind computer screens and televisions have an awful lot of radiation in that critical 460 to 480 nanometer region that we consider to be the action spectrum of circadian response. Is this a good idea or not? I have some doubts as to whether it's a very good idea. The unstable blood pressure at this period, unstable mental and physical states. Feel a little weird? Well, it's about that time right now, isn't it? We're hitting that time. No wonder we're feeling weird. Body temperature begins to fall. Melatonin secretion, now it begins. Here comes the vampire enzyme. It's going to get into your blood, and it's going to really slow you down. Cortisol level is the lowest, and beginning your lowest performance period. In other words, don't try to do anything really, really great after about 8 o'clock at night, because you're really into your lowest performance period.
And 8 o'clock at night is also a key critical, almost anecdotal time period. Your grandmother, my mother, and her mother before always said, don't eat after 8 o'clock. Well, science is now showing the validity to that because of the clock, the biological clock that's located in the liver, as well as setting us up for melatonin secretion later in the evening. Particularly red meat after 8 o'clock is something that we may want to consider avoiding because of the vampire impact that it has on melatonin production. So it will, in some cases, actually hamper the production of melatonin later on in the evening hours.
So here comes 9 o'clock. Your core body systems are performing fairly steady. Your metabolism is low. Now your melatonin is rising, cortisol falling, serotonin is low. And of course, the light levels in nature would be low at this point. There's some really strong theories that this is a good time to turn off that television and turn off that computer screen and rely upon low color temperature light sources, incandescent lighting, candle light, maybe some LEDs that would be tuned for this purpose, and trying to avoid the short wavelength light sources. You have your lowest pain threshold, your peak hearing level. That's interesting. Blood pressure begins to fall. Body temperature starts to fall. Multitasking ability is at its worst. So at 10 o'clock at night, don't try to do any more than one thing at a time, okay? Either chew gum or walk, but not both. Estrogen levels rise, ghrelin levels rise, and at 22:30, your bowel movements stop. And if you haven't thought about this ever in your life, there's a reason why, chemically, that those things don't happen at night. At about 11 o'clock, your allergic reactions are going to peak. 11:30, your ghrelin levels rising again, and we're back to midnight. All of that happens in a perfect circadian day. I want to say two things that are critical to remember about this perfect circadian day we've just seen. Number one, this is a perfect circadian day without electric illumination. Number two, it's a perfect circadian day for a normal adult. We could shift everything 2 to 3 hours for teenagers, give or take, right?
It depends. It depends on what we're trying to test at this point, because the research is not 100% clear. What we are certain of is that the teenage brain is physiologically not as robust as an adult brain. It's going through changes, and we need to honor those changes by allowing the teenage brain extra time to sleep for the physiological changes to occur and for that brain to be able to be at its optimal best. After 9 o'clock, actually after 8:30 is when it's now thought in the scientific circles to get the first light levels. Whereas everyone else, young children and those folks that are considered adults up until the age of 65, science and medicine are coming to a common almost recommendation at this point saying, yeah, everyone except teenagers, we need to get light as close to 6 o'clock as possible in the morning. Teenagers, 8:30. So we're going to start sending our kids to school with, blue blocker glasses on. And school bus riding a lot later.
Yeah. Try and get my teenagers out of bed before noon on Saturday. That would be an accomplishment. Anyway, consequences. Well, our perfect circadian day is interrupted by our lives. We've come to rely upon electric illumination and a lot of other things, and there's consequences to those decisions, aren't there?
Very much. See how we segued into that one? He knows he can read my body at this point. So we have consequences. And no, it's not, this guy didn't get the memo. Everybody's wearing black and he has the other odd color, and it's like, oh, okay, I see that. There's consequences. There are economic consequences and social consequences as well. Fatigue. Fatigue worldwide is a huge problem in terms of the dollar loss, directly attributable to folks getting the wrong amount of sleep at night. Even 1 hour less of sleep has dramatic results in fatigue levels. And several scientists have been able to calculate that in the United States alone, it's $15 billion per year directly attributable to somebody going to work tired. Those people. Is my perpetual timekeeper here. We are not a half hour late. We are just 15 minutes. So give me a minute here. So we have these dollar amounts. We have these dollar amounts that we're taking care of. Reduced performance and productivity. It's now up to $65 billion here in the United States alone, and it's directly calculable. We now know that simply by getting 1 hour less sleep a night, employers can actually add $1,967 per employee per year for lost productivity to their bottom line. $1,967 per head because their employee slept 1 hour less than they were supposed to. Incredible. Accidents and obesity levels. Accidents, 100,000 accidents per year in this country are again attributable to driving tired. 16,000 deaths because, again, fatigue. And this is not falling asleep. This is just being tired and not having the reactionary response. And obesity, these numbers are kind of interesting. A study done in Colombia actually figured out that simply by getting 1 hour sleep less a night, women will consume 328 additional calories per 24-hour period, and men, 289 calories. And believe me, on autopsy, when you look at cortisol-derived stress, or when you are not paying attention to what your body and brain need, the fat that's derived from the stress is bright orange, and it's right here in this area of the body. And it's a different consistency and a different color than normally derived fat throughout the body. So you can see the stress. You can see it in the body itself. And the interesting thing is that now science, through sleep medicine, is tracking how and why some individuals can maintain a svelte body and others will go to something that is now a problem in the world. The World Health Organization in 2010 showed that we have billions of people. What were the numbers there? Read me the first line, please, in this last sentence. My brain, it's already 7 o'clock at night, so I'm forgetting. But basically, we're looking at 300 million people right now in the world are considered overweight. And 3 billion people are obese. This is incredible, World Health Organization. Absolutely incredible numbers. And if by getting the right amount of sleep can help with that problem, and if by getting the right amount of light during the day can help with the sleep problem, start connecting those dots. And what Jim was saying about the melatonin, you know how it involves in this? Well, you want dark at night to produce melatonin, but you want to squash the melatonin levels down during the day. You want to keep them low. And the only thing that's going to keep melatonin low during the day is high light levels of at least 1,000 lux. Throughout Europe right now, there's a big push to keep light levels in offices at 200 lux. The term is now circulating there called biological darkness. In other words, you're never fully waking up. So how can you squelch melatonin so that you can get it produced at night? You know, and it has a consequence. $12,000 per year per employee in health-related costs. And it can be traced back through poor sleep, poor efficacious sleep. And so if light can play a small role in that, wow, who knew? Light bulbs can do all that. It's incredible. So what Jim and I have tossed around, and we banter, and you can tell that, you know, he keeps me on my P's and Q's, and I keep him under control from time to time. Yeah. And what we've come up with is some common language, some common terminology that is called circadian adaptive lighting, so that we can give lighting designers, architects, interior designers, and homeowners some ideas of how to use the correct lighting at the correct time of day in the correct dosing. And the dosing protocols for exactly the critical times, the scientists and medical practitioners are still hashing that one out. But we know enough to how to keep this on track and to help provide a better world. Jim's going to speak that, and then we're going to get out of here because our times for fully functioning cognition is draining drastically quick.
You can tell there's a lot of material here, and,
yes.
We don't get to rehearse this all that often, so apologize for running a few minutes late. We will be wrapping up here in about 5 slides. First of all, I want to stress that this is new stuff. I don't know of any existing protocols, save a very, very few. There's been a few situations that I know of, NASA and darn few others, where people have actually gone to the trouble to try and create some of what we're going to talk about here. Well, we're just starting the conversation because these are the descriptions that Deborah's taking to the IES, the appropriate photobiology committee, and starting to introduce the language into the IES so that we can finally start talking about these as protocol-based philosophies. First of all, the use of epigenetic design to literally come up with a language by which we can say it's this type of project or it's that type of project. The word epigenetic itself, now that you know what it means a lot. But it's not a common phrase from our terminology. We've had many debates about how to say things a little bit better. And so the whole idea of circadian adaptive lighting made sense because most people have heard the expression circadian and kind of got an idea what it means. But one of the things that really challenges us about all of this is the concept of dynamics. We're used to designing a room with 100-foot candles or 50-foot candles or something. We're not used to designing something where the lighting is intentionally dynamic for a photobiological purpose. Other than the few of us, and there's a few lighting designers here, and I know some of us have been asked to design like parts of zoos and other things where animals or plants are being literally given an artificial circadian rhythm, an artificial circadian cycle. Well, those dynamics are magnified, and part of my passion about daylighting design is how do we take daylighting, which in and of itself is extremely dynamic, and match this up to this entire system. It's getting to be pretty complicated. But we came up with 3 primary protocol-driven ideas that would lead us to design philosophies. One of them, circadian restoration, one of them, circadian maintenance, and one of them, circadian emulation. Think about what the words mean for a second, and it becomes pretty clear. Restoration is going to be a clinical protocol. This is where someone is really off cycle. Now, I don't know how directly this relationship goes, and Deborah may end up correcting me, and I'll leave it to her to do that, but one of the things we noted is that there are places in America, particularly Seattle, where there seems to be an unusually high degree of seasonal affective disorder and winter problems, right?
Yes, and also suicide.
Suicide.
As a direct response.
And part of this is because if you look at the weather charts for Seattle, you realize there's no clear days for most of the winter. I mean, literally, it's 90% cloudy days in January, February, March in Seattle. So the body clocks get messed up. And so a circadian restoration might be used in the most critical of these situations as a clinical way of restoring them. Circadian maintenance, this is where we mimic natural lighting shifts. And part of the reason for doing this is because we want to help people stay on that rhythm and stay on that system.
And this is particularly adaptive for long-term care facilities and Alzheimer's care, as well as patient environments. Because as so many of us know that have been hospitalized, when you're in the hospital, one of the things that you desperately need, you don't get, which is sleep. Because the nursing staff is continually coming in to check your vitals, and you are deprived of sleep. So circadian maintenance lighting is a type of lighting that can be adapted for, again, those healthcare areas, as well as in certain daytime environments where your employees do not have access to direct natural light, and they need to be able to keep on track with the changing light levels throughout the 24-hour period or during the daytime if they're working during the daytime.
Finally, the circadian emulation. This is one that we have found, I think, very interesting, because this is one of the first easy opportunities for us to say, oh, we could do that. And that would be places where we do a lighting intervention. So we literally create or recreate an artificial world. That is a world where day is night and night is day. Okay? So we're going to emulate the circadian cycle, but you may be getting up at night and going to sleep in the morning.
And this also involves paying attention to all of those natural changes that we detailed throughout the dashboard. Jim had said several times where serotonin was rising and then it fell and then it rose again. Well, this is the prime opportunity to impact or emulate the light as well as help it by providing blue wavelength light at key critical times throughout the day in order to elicit a specific response. And throughout Europe, there are several projects that are having great success with this. And this also applies to the night environment, the night shift workers, helping them because they also have a circadian need, even though they are living an anti-circadian lifestyle. Their system still needs to respond appropriately. And so if we are able to provide the right type, the right wavelength of light at the right time, at the right dose, the right dosing protocol, we would in fact be able to create a perfect environment for them. We would emulate the daytime environment during the evening hours while they are choosing to work.
Here, in fact, are examples of some projects where circadian maintenance has been used in senior care facilities. It's a process by which color, temperature, and intensity are varied to emulate nature, reinforce nature cycles. Now, one of the things that I strongly believe in is that daylighting is a powerful tool for doing all of this and doing it energy efficiently. So it's been part of my passion for even getting involved in this process was not just to make buildings more energy efficient by daylight, but making them healthier because of daylight. So I'm really pushing in my designs to see buildings that have more daylighting, not less, because of all those benefits. Then there's a circadian emulation where we literally can create those environments that help people who have to work in these anti-circadian cycles. Deborah and I were engaged to design for a 24/7 emergency operations center control room last year. And the whole process was, how do we do lighting in the facility so that people can literally work the graveyard shift? One of those facts I threw at her a while ago was, look up how many serious control room accidents, particularly nuclear accidents, occur during the graveyard shift. It turns out accidents not caused by tsunamis was all of them.
Every single one. the chemical explosions in Bhopal, the nuclear accidents, even the Titanic occurred during the graveyard shift.
And
it's
so,
incredible.
And so it's a process by which workers have got to be trained how to live a lifestyle that reinforces the benefits of your design of your facility. In other words, you can't design a facility, and if the worker doesn't do their job, no benefit. It's an entire protocol of worker lifestyle as well as design a facility.
And it's also applicable for daytime environments. This is a slide of a conference room. And may I have the flippy? Thank you. And basically what you're looking at here is 2 different light levels for 2 different times during the day. So in other words, you get to work and your body temperature is warming, but your need for light is a pool-based light. So throughout the day, you would be getting varying temperatures of light, but there you are getting ready to go home at night, and it's 4 o'clock in the afternoon, and you're going, I feel kind of tired. So with circadian emulation, this is where you would go back to the blue light level and pump up for that very small critical window when serotonin is starting to rise to give it a little extra boost, and then stop the blue when serotonin is naturally falling to be able to enable the worker to go to work, go home correctly. So in other words, we would be following the human performance based on cortisol levels in the system, as well as naturally occurring serotonin levels. So in the future, designers and architects and lighting designers are going to need to know a lot more about this body and brain, because their work is going to be dependent upon their knowledge. Because we know too much now. The genie's out of that bottle. We know a lot. And the environment that we so capriciously design from time to time based on aesthetics is really impacting a lot more than we understand. So in summary, Jim's going to summarize this up, but I'd just like to say one thing. We need to understand that when we design a space, it's not just about aesthetics anymore. It's about the body and the brain. If we design appropriately to support the body and brain, everything else will fall into place, and we truly will have an environment that's sustainable, that's energy efficient for the body, not just energy efficient for the power companies and our bottom line on our bills. We'll be energy efficient in here.
So, what is this going to lead us to? Well, we're going to have to learn how to do dynamic lighting and dynamic lighting technologies. But it's not as simple as turn on this then and turn on this other light source then. It's going to be more complicated than that, and we're going to have to learn all of this. Lighting systems will be invented and developed. Lighting control systems will be developed, of course. Solid state lighting is the perfect tool for doing a lot of this, near as we can all tell. So it's going to be a very exciting period in lighting design in buildings. But it's not as simple as just changing from warm to cool. It's a matter of timing, duration, and the other aspects of dosing that we talked about here today. One of the reasons why I chose to team up with Deborah, other than I happen to be rather fond of the lady, is the fact that she's the one who does amazing research and points out the complexity of these connected dots, which is what we're all going to have to learn to understand to a certain level. Now, we're going to expect manufacturers to make products. We're going to expect research groups to give us clearer direction. We're going to expect protocols to evolve. They're going to tell us what we have to do, why, when, how. All of that's going to occur. But I can predict that just like dynamic lighting technologies are going to be part of our portfolio of products in the future, so will natural daylight. Natural daylight, for most people, most circumstances, most problems, is the obvious, easy solution. We've got to design buildings where people are exposed to it and encouraged to take advantage of it. We also have got to design darkness. We cannot continue this runaway light pollution we seem to think we have to have everywhere. There's legitimate science pointing to this, as a pollutant, not just because it doesn't allow us to see the stars, which I think is important. It actually may be a pollutant in many ways. We're going to have to learn to use shading as well. Lighting designers today are learning to be shading designers too. And the reason for that is because our control of natural light is going to be just as important as our control of electric light.
And the allowing of complete darkness. So in addition to providing shading and shade filtering options on our window surfaces, we will also have to provide blackout shades, so a dual shade system, in order to be able to address the biological need of the body.
And finally, the last point is that the knowledge base that we're going to have to develop is going to require research. And to bring us all back to the CLTC and the wonderful work that's being done here, this is going to be one of those places where these things are going to come from. Your support of CLTC and your interest in CLTC and the continued investment of the California utilities, the California Energy Commission, CPUC, and others is very much appreciated, because from here, the knowledge is going to come, and it's going to be presented in programs like this and throughout the country as the papers are presented and the word is spread. So on behalf of my colleague Deborah, I'd like to thank the CLTC and for the opportunity to be here tonight. Sorry we ran a little late, but we get into our stuff a little bit deeply, and it sometimes...
Well, we are officially 2 minutes over.
We're officially 2 minutes over what we said we were going to do. So Deborah was right. I thought we were going to run way too long, but we're in pretty good time. We will field a few questions. So for those of you who feel that it's past time and you need to get going, because we did start late because of traffic, we won't mind if you get up and leave now, but for those who'd like to ask a few questions, we're going to have some microphones and we'll do our best to answer them. Thank you.